Welcome back everyone. In this video, we will explore what constraints are, why they're essential for maintaining data integrity, and how they can elevate the quality of a database design. So, without further ado, let's get started. SQL constraints are rules or conditions applied to the data stored in a database table, designed to enforce data integrity and maintain consistency. These constraints define limits or criteria that the data must meet to ensure its accuracy, completeness, and validity. Now, you must be wondering, what are the importance of constraints? SQL constraints are rules applied to the data stored in a database to enforce integrity and consistency. SQL constraints play a crucial role in maintaining data quality, preventing errors, and safeguarding the integrity of database structure. They help maintain data accuracy, prevent unwanted modifications or deletions, and ensure that the database remains reliable and functional over time. In short, SQL constraints are essential for ensuring the reliability, accuracy, and consistency of data within a database. Now, let's look at the different types of SQL constraints. The different types of SQL constraints are not null, unique, primary and foreign key, check, and default. Now, let's look at each of them one by one with an example. In SQL, the not null constraint is used to ensure that a column cannot contain any null values. Essentially, it mandates that every row in the table must have a value for that column, preventing the insertion of null values. Now, let's look at an example to understand it better. For this example, we have created a table called students, which has the following columns: roll number, name, class, and section. Now, if we execute this query, we can see that we have this table in the database. Now, if I just remove this one from here and write null, also the second one, and write null, and run this query again, and now you can see that roll number 1 and roll number 2 is missing. It contains null value, but we know that roll number should be one criteria that shouldn't be null. So, to make sure that the person entering the data doesn't enter any null value, we can add the not null constraint. So, how can we do it? Just under the create table section near roll number, write not null. And now, if you run the code, it will show you an error. You see, it shows that roll number cannot be null. So, it will remind the person who's entering the data that the roll number column cannot be null. Now, if we change it back to 1 and 2, and now run it, you can see that it will get executed properly. In SQL, the unique constraint enables all values in a column are distinct or unique. It prohibits duplicate values from being inserted into the specified columns, thus maintaining data integrity and consistency. This constraint is essential for ensuring that each row in the table contains unique information in the designated columns, preventing data redundancy and facilitating efficient data retrieval and manipulation. The syntax here is that you will write the unique keyword after the column name. Now let's look at an example to understand it better. In the previous example, let's first remove the not null keyword. Now if we just run it, we can see the table is this. Now, what if we repeat the roll numbers, like for roll number 3 also we write roll number 2 and run it. We see that the query gets run and we are returned with this table where two different people have the same roll number, that is 2. But should that be the case? No, right? So we have to make sure that roll number is one column that is always unique. So again, after roll number, give a space and write unique. And now if we run this code, you will see that it will show an error that there is a duplicate entry for 2 roll number. This will again remind the user who's entering the data that roll number is a column that should be unique. So now if we write 3 here again and then run, you see now it gets run properly. So this is how you can use the unique constraint. A primary key is a column or a set of columns that uniquely identifies each rows in a table. This means that no two columns can have the same primary key value and the primary key column cannot contain null values. Primary key constraint ensures both uniqueness and non-nullability for the specified columns in a table. So the syntax here is that after the column name, you will mention the word primary key. Now let's look at an example. In the previous example, we have used the unique constraint. Now, in place of 1, if I write null and then run it, you will see that it will return the value with this table. But we know that roll number should be one column which should not be null as well as unique. So what we can do is, instead of the unique constraint, we will write primary key. And this key will make sure that we can retrieve the entire data from this particular value. So like if we write roll number 1, we can get the value of all the details of the student who has the roll number 1. Now if we try running it, it will throw an error because we have null value here. Now, if I just change it to 1, you see, it will then return this value. Now, if you try to duplicate it, say let's write it 2 and then run, it will again throw an error because primary key cannot be duplicate as well as cannot be null. Now let's correct it and then run again. This is how you can use the primary key constraint to make sure that a column is not null and also unique. In SQL, a foreign key is the column or a set of columns in one table that references the primary key or unique key in another table. It establishes a relationship between two tables by enforcing referential integrity, ensuring that every value in the foreign key column of one table matches a value in the reference primary key or unique key column of another table. So this is the syntax which you can see in the screen. And now let's look at an example to understand it better. Here we have two tables, customer and orders. Now let's look at the table one by one. Now if we run this, the customer table has customer ID and the name. And now if we write orders and then run, you see it is the order ID, customer ID and total amount. Now in the customer table, we can see that the primary key is customer ID. The same customer ID is also available in the order table. We want to link this customer ID with the primary key of the customer ID in customers table. So how can we do it? We can do it with the help of a foreign key. Now let's add a foreign key. Foreign key customer ID references customers customer ID. Now if we run it, we can see that the data is same, but now this customer ID is being referred to this customer ID of the customer table. So we can see the customer ID, which is not a primary key here, is referring to a primary key of the customer table. So this is how you can use the foreign key concept to reference the primary key or unique key of another table. A check constraint in SQL is a type of constraint that allows you to specify a condition that each row in a table must satisfy. The syntax is, while creating the table, once we define the column name and the data type, we will write the keyword check and then the condition. Now, let's look at an example to understand it better. Let's consider this example where we have the data of a following employee whose name is John, his ID number is 1 and his age is 21. Now, if you want to put a check constraint saying that the people who are working here should be of the age of more than 21. So after age, write check age greater than 21. And now when you run it, it will show an error because the constraint is violated because the age is 21. But as soon as we change the age to 22, it will satisfy this condition, and once we run it, you see it's now accepted. So that's how you can use the check constraint. A default constraint in SQL is a feature that allows you to specify a default value for a column. The default value is used when a row is inserted into the table if no explicit value is provided for that column. The syntax is, after creating the table and the column name, just write the term default and then the default value. Now let's look at an example to understand it better. Now in this example, you can see that we have the following data. A person with the name John, his ID is 1 and his age is 22. Now if we remove age from here, also from here, and we run it, we'll see that in the age column it's filled with null because we haven't entered any value. Now, if you want to put a default value, that if we forget to put the age value, it will be by default 18. How can we do it? So after age, write default 18. And now when you run it, you will see that the age is by default filled as 18 because the default value is 18 and we forgot to put any other value. So it will take the default value that is 18. So this is how the default constraint is used in SQL. So with this, we come to the end of this video. SQL constraints play a crucial role in ensuring data integrity and maintaining the consistency of a database. Understanding and implementing these constraints not only enhances the reliability of a database but also contributes to its overall efficiency and usability. If you found this video helpful, don't forget to like, share, and subscribe for more content on SQL and database management. Thanks for watching. See you in the next one.